Good evening, everyone. This is Daniel Pinheiro from danielpm1982.com, and welcome to one more video about Docker. This video is a sequence of other videos I have already published, so if you haven't watched the first videos, you should first start from them so that you can understand what we are doing along the other ones. So in this video, the objective is how we can run MySQL, and for that we are going to show you basically two things we haven't shown you before, which is how you can map the internal volume of a Docker container to your local file system. We have the volume inside each container, but if you don't map that to an external volume, as soon as you delete that specific container that you're eventually running, even if you create other containers, that data will simply be gone because the volume is associated or included inside each container and not at the image. The image is immutable. So when you download an image from dockerhub and you run it, and then you have a container created from it, the volume where any data that's going to be manipulated inside that internal file system of that Docker container is saved inside each container. So if you eventually exclude that container, all the data you saved there will be gone. So in the case especially of database management systems, if we want to have that data saved, we gotta map to any place or any folder in our local file system. So that's basically one argument you gotta set when creating the container or running the image. Another thing is the mapping of the ports that we have already shown you. We gotta externalize the internal port of MySQL that will be running inside our Docker container to any application or to the system outside that Docker container, so that you can access that DBMS running in the container from outside Docker engine. For example, from an application that you're running in your file system or even in another container. We're gonna do that in the next videos. We're gonna run more than one containers and eventually create a cluster of containers. And one last thing that we are gonna learn is how we can get into any specific container and execute a shell command, for example bash or sh, in order to manipulate the system, the operating system inside that container. So after we run the image and start the container running MySQL, we're gonna get into that container and execute MySQL command and use MySQL CLI to create a database, create some tables, and do some queries over that table we're gonna create. And we're gonna test the MySQL command both from inside the container by using the MySQL CLI commands, and we are also testing it from outside the Docker engine by running Workbench from outside and making the connection between the outside and the internal environment of that Docker container through the port mapping that we're gonna use. And that's important because in other videos, as I said, we're gonna access that container running MySQL from other containers running springboot applications. So, but for now, what I simply want to do is to access the MySQL process, both from inside the container as well as from outside the container, for example, from Workbench. And of course, this is only one way of using MySQL. If you do not want to use Docker, for example, you're not forced to do so. You can simply install MySQL from, for example, a MySQL repository by adding that repository to the apt package manager from Ubuntu and install both the MySQL server with all its dependencies as the MySQL Workbench for the operating system you're using without needing to use Docker. But here, as this course is about Docker, what I want to do is to show you MySQL DBMS running from inside the Docker container. And if you want to know how to install MySQL Server as well as MySQL Workbench in Linux or specifically in Ubuntu, you can go to my YouTube channel, just search for Daniel PM1982 at YouTube app or YouTube page, and you find there a playlist with an entire video about how you can install a MySQL server and MySQL Workbench and test it in Linux. So enough talking, and let's go to dockerhub and look for MySQL official image so that we can run it and then test it. So at dockerhub homepage, just go here at the search field and look for MySQL, and you find this official image of MySQL that is created over a Linux operating system, as most of the images at dockerhub. So as you enter at this official image of MySQL, you have here all the documentation about it, a quick reference with some links about this image. Here you have the supported tags and the links for each Docker file. For example, you have here 4 tags, and each tag, if you click it, the one we're gonna use is the second one here. If you click it, it'll go to a GitHub page where you can see the whole image script about that image tag. For example, with the volume path inside any container that is created from that image, as well as the ports that it exposes, 3306 and 33060. So we're gonna use this second tag here of this MySQL repository. And here down below you have also some instructions about how you can use this image, including how you can run it, how you can connect from the CLI of MySQL. That's what we're gonna do in this video. How you can use Docker Compose with this image, how you can access or execute any shell command from inside the Docker containers created from this image. That's also one thing that we're gonna do in this video. How to use custom MySQL configuration files. We're not doing that. How to use the environment variables, and the one we are using is the only one that's requested for running the image, which is MySQL root password. It's mandatory that you set it when running the image. That's the only environment variable we'll be using. And down below it also shows one of the important things we're gonna show you in this video, which is how to store the data that's going to be manipulated by the DBMS not only inside the volume of the container, but mapping that to the volume of our local file system in order to save all the data from that container in our own operating system so that we do not lose it when the container is erased. And also how to use MySQL image or containers by leveraging any already existing data. And we also show you how to do that. Any MySQL existing data from our local file system from outside Docker. So the basics, all the basics you have here about the commands at this very same documentation about MySQL official image. So for running it, we will simply have to use the MySQL name, which is the repository name, and for the tags, for any of these are the same tag, so we can use either of these. We are gonna use column 8. So for running this image, we're gonna use MySQL column 8. Or we could not use the tag and it would run the latest tag here, which by default is what it selects when we do not pass the tag and only put the repository name. So, but to be explicit, we'll be using the repository name column 8, and it will run this tag, which is actually this script here from our Docker engine. So let's go to our terminal and ask Docker to run this image. Okay, but first, before we run the image, as we want to map the internal volume, the Docker container that will be created from that image to our local file system, let's first create here a temp folder. I think I already have created. Yes, it has no files at the moment, so I have an empty folder here called temp, and inside this empty folder I'll create a specific folder for us to be able to store all the data from the internal volume of the container of MySQL image we'll be running to this external file system folder. So let me create Encoders, for example, SQL data. So now inside this temp folder, at my home folder, I have this other folder, SQL-data, that we'll be using to have mapped all the data from inside the SQL container to outside, specifically to this SQL data folder. So now we can run the image. So sudo docker run. Let's use here the name for the container we'll be creating, and you can use any name. So the name, let's use -g for detached, because this MySQL image, when it has the container created, that container will be running in the detached mode, and by that it means that it will be running in the background. It will not terminate as soon as the script ends, but it will keep running as a background or as a daemon service in the background. So -g for detached. Next, let's also define map the ports. So the 3306 will map to 3306 outside. So this second port, as we have already shown you before, this second port here is an internal port inside the Docker container, and this other port here is an outside port that will be mapped to this internal one. And it's a good practice to keep the same port numbers, so we do not confuse that later. So the standard MySQL port is 3306, and we're gonna map the port from inside the Docker container to the same number port at our operating system. So 3306, and also another port that MySQL uses, which is 33060. So we're mapping here at the same time two ports from inside the Docker container to our operating system, the 3306 and 33060. And we map that through the -p parameter. Now the next very important thing that we're going to show you for the first time now is the mapping of the volume, which is another parameter, -v. And similarly to the mapping of the ports, we have the second value of that parameter after the column as the internal path or folder where the volume is saved inside that MySQL container, and outside we are going to use the SQL data folder that we just created, and all that data will be saved and protected outside the Docker container so that we can later erase or delete that Docker container as well as the image, because all the database data will be saved externally. And another requested parameter is the environment variable parameter, through which we're going to set the only requested environment variable, which is the MySQL root password. And don't forget to use the underline here. It's not showing because of the color set of my terminal, but you have here MySQL underline root underline password that will be equal to, let's put it as root, so that we'll have a root instance and also a root password for that instance. And finally, the name of the repository, MySQL, colon, the tag that we're gonna use inside that MySQL. Remember that we can have many images, and each image will be identified through the combination of the remote repository colon the tag of that specific image, in our case colon 8. So in short, we're gonna call sudo docker run for running this MySQL image and creating its container, for then use that container for testing MySQL DBMS, --name and the name of the container we are creating, -d for the detached mode. Later, when we go into the container to execute some shell commands, we'll be using the iteration mode, but for the container itself, what we have to use here is the detached mode, because the MySQL service inside the container will be running as a daemon process at our background, regardless of whether we get into it to use any shell commands or not. Also, the mapping of the ports, we're gonna map these two ports from inside the Docker container to our operating system outside the Docker engine, which is the port 3306 as well as the port 33060. Next, we map the volumes from the default folder inside the MySQL volume, where all the data for the databases is saved. So it will automatically be mapped to an external folder that we have created here, SQL data outside the Docker environment. So that's all the data from any database we use, or for any tables or any kind of data we use along with that database will be saved outside that Docker container. So we are not limited to have that container saved in order to preserve the data, because we're saving all the data outside the Docker container. So we will be able to delete the Docker container as well as the image, and later reinstall the image or rerun the image and create a different container. That container will then get all the data from the external source folder, will be mapping to it, so that the data will be reused by any container we install from that image, as long as we map to the correct folder where the data will be saved. Next, the environmental variable that's required for the running of the image, which is MySQL root password, that will be setting as root. And finally, the image name column, the image tag, which is the version of the image we're going to download from dockerhub and use to create our MySQL container. So everything's okay. You just have to hit enter. Sorry, I forgot that if we're mapping multiple ports, we gotta use multiple parameters or attributes -p. So for this port 3306, we use a -p, and we use another -p for this other port 33060. Okay, so now let's press enter. So it's looking for the image locally, it's not finding. So it goes to dockerhub and starts downloading it. And next it's going to create the MySQL column8 container. And another error here. Actually I will not cut the errors because I want to show you the exceptions that Docker Engine may throw. So in this case, the problem is that we cannot use relative paths as for mapping the volume, so we gotta use the full path. So let me clear here and correct this other thing, which is to use the whole path, which is / for the root directory of my operating system file system, home /Daniel /temp, and now /SQL-data. So this is the complete path to the folder where we'll be putting all the BMS data from inside the Docker container to outside this folder. Enter. Okay, it ran successfully. It had already downloaded the image from dockerhub, the MySQL column8 tag image, and now it simply created the container, mapping the ports and mapping the volumes, and also passing the environment variable. So now let's see, sudo docker images. We have the image downloaded, and if we use ps-a, we'll have all the Docker containers available. And if you see here the status for this unique container we have, it's up and running. Why? Because we set it to run in the detached mode. So it ran the script of the container and it kept running it in order to let it available for future requests. So you have here the name, actually the container ID, which is this one, the source image, which is this image here, MySQL column8, downloaded from dockerhub. We have here the entry command, which is from inside the Docker image. We have here when the this Docker container was created. We have here the status for that container. It's up and running in the background. Here, importantly, we have the ports. So as you see, we have both the 3306 TCP IP port mapped to our system 3306 port, and also the 33060 port from inside the container to the external operating system port 33060. And here, lastly, the container name, and I set it as Daniel 1982-SQL-container. So, as you know it, we can use either the container ID or the container name, and the same for the image. We can use the image ID or the repository column, the tag, for setting it in any of Docker commands we wish to use. So now the next thing that I wanna show you is how you can get into this running container in order to enter the MySQL CLI client to test some MySQL commands, not only for this container, but for any other running container where you can get into and call any Linux commands or something like that. You can use sudo docker exec or execute, and in this case we'll be executing it in the iteration mode using the terminal. So you gotta use the -i for the iteration mode and the T for saying that you'll be using the iteration mode in the current terminal. So -it, and next the container ID or the container name for specifying which Docker container you will be getting into in order to call any Linux command. In our case here, the bash command, which is available and must be available inside that container already installed. So I have already tested that the bash command is available inside this container created from this image, which in turn is created on top of a Linux image. So we have a Linux image that was used to create this MySQL image, and now we are getting into the container and be using that internal operating system of that image or container to run some shell commands, in this case the bash command. So in short, we'll be using the sudo docker exec command -it for the iteration mode, the name of the Docker container we'll be getting into, and the shell command or Linux command bash that will run from inside that container. So let's press enter. Okay, we are now inside the Docker container created from the MySQL image. So we can use here any Linux command or Unix command that is installed inside this container. So we have basically an image Linux operating system inside the container itself, along with the MySQL program or processes. So we got into that specific Docker container, and now we can call the MySQL command and get into the MySQL CLI client so that we can test accessing and creating databases and tables inside those databases. So let's use here the MySQL command. You can search for it at MySQL CLI at MySQL documentation, or you can look for any tutorial about it. For example, this one. And you have a list and some examples of the commands you will be able to use with the MySQL program or MySQL process, which is a client process for the MySQL server already running inside this container. So the container has started as well as the MySQL server, and we have here a client program or a client process that can be run in order to access the MySQL server and do any DDL or DML commands over the databases that MySQL server is managing. So we have the MySQL server and we have any client that can communicate to that server. In our first example here, we will use the MySQL CLI client from our command line, but we'll be using later, for example, another client which will be the Workbench GUI client. And we could also use any springboot application that would communicate through the port mapping or directed to the port 3306 that will be communicating to the MySQL server that is running as long as this container is in the app status. So we know that the MySQL server is running because the container is up. So as the server is running, we can use any client to communicate with that and show some results. So let's try to use some of the commands from this MySQL CLI client. And for entering the MySQL CLI client, we simply have to call from inside the Docker shell here. We call MySQL-u from username, and the username initially will be the root username, and we also type -p, and p here is not part, it's password. So we're entering MySQL CLI client, passing as user the root value and passing nothing as the password, so that as soon as we hit enter, it will demand a password for that root user instance of MySQL. And as you remember, the environment variable that we used as the password was also root. So we just type root as the password for this username root. Root. And now we're in the MySQL CLI client. And now we can't use Linux commands here. We gotta use the commands that MySQL client turns available, which are basically these ones. But you can take a look at others at the tutorials. For example, this tutorial here, you have lots of other commands. And let's, for example, ask for it to show the databases. And also, when you're inside the MySQL CLI client, you always gotta use, especially for the queries or for the DDL or DML commands, you gotta use the semicolon at the end of each command line. So show databases. Here are the databases that we have in our system in the volume of this Docker container. And remember that this volume is mapped to outside the Docker environment to that specific folder that we set. So if we, for example, go here to the temp folder, and inside that temp folder we go here to the SQL data, which is the folder we created and mapped. We'll see that all the data that inside that container the Docker engine is managing, it is mapping to outside the Docker container to this folder here. So all the databases that we create or any alterations on the databases that are already there created will be persisted or will be saved in this initial empty folder that we had, but that now has all the data mapped from inside the container. So all the data will be saved here, so that later we can erase both the container and the image and not have all the data from our databases erased together. So the data will be preserved here, and later we can download again the image and create any other container from it, mapping back all the data from this external folder, as long as we keep this folder to be mapped later with the volume inside the MySQL Docker container. So we can also use the use command to select any of these. For example, we have here 4 databases: information schema, MySQL, performance schema, and sys. These are 4 databases we have. So let's use, for example, the MySQL. So as you see here, it has read the MySQL database, and you have a confirmation message saying that the database has been changed or a new database has been selected. So now we have this MySQL database selected, and we can show the tables we have inside that database. But don't forget to use the semicolon at the end of each command line. So these are the tables that we have inside the MySQL database, which is a default database created with the MySQL installation. So I'm just showing it as a simple one here. Later we'll create a database of our own, but when using the MySQL database here, you can see, you can show the tables, and if you wanna have more details, you can use the describe command over any of those tables. For example, inside this MySQL database, let's see this last table here, user table. So we can use the describe command to show the schema of the user table inside the MySQL database. So describe user. User is the table. Don't forget semicolon. So this is the complete schema for the user table that is inside the MySQL database we're using. So you have here the column name of each field of that table. You have here the types. You have here if these fields are nullable or not. You have here if the primary key or not. You have here if they have default values and all eventual extra information about those fields. So this is the describe command. And next, what I want to show you is how to use this table inside the MySQL database to select, for example, these 2 fields, host and user. So let's select our 2 fields, host, common, user. Select these 2 fields from the name of the table, which is also user. So you have the table user and you have a field inside that table which is also user. So we are selecting here two fields. We could use a star for selecting all the fields, but I'll just select these two ones as an example. So select host field and user field from the table user, semicolon. Okay, here you have the two fields from that table with their values. So for example, here you have for localhost, you have a user info schema. Also for localhost, you have the session, user session, user sys. You probably never be logging with these user names. They exist for the MySQL processes to be able to access the databases, but you probably never have to use any of them. The ones we'll be using here is the root that we have created when setting that root password at the running of the image. So we have the root user both for the local host as for any host from outside, for example. And the password is the value of that environment variable that we have set. In our case here, also root. So we have user root and the password root, which is the one actually that we are using right now. So let me show again the databases we have. We have these four, and let's, as an example, let's use DDL commands here to create a database of our own. So for creating a database, we use the standard DDL command create database, and the name of the database. I'll use DNP 1982 DB and semicolon. I always forget. Okay, now if we ask to show all the databases we have, now we have database DNP 1982 underline DB. So we've created this database so we can select to use it. Okay, now we are using the Daniel Payment 1982 underline DB, and now we can show all the tables inside this database. Don't forget the semicolon, which is actually empty because we have no tables yet. So let's create two tables here so that we can later do a join command. So I'll create a client table and an address table, for example, so that I can later do a join between them. So for creating a table, also we'll be using the DDL commands. In this case, create table command. Create table, the name of the table, let me use client, then you open parentheses and you pass the fields for that table along with the constraints. So the first field always is the ID, which will be the primary key. So ID, and next the type, the data type, let's set it as int, and as the ID, actually let me use, instead of ID, let me use client ID to keep all the fields with unique names. So the field name will be client underline ID, data type will be int, and it will be a not null field, common. The next field will be, for example, client's name of type varchar. Let me set the maximum size here as 255, and the value for the second field can be null, so I'll not use not null, and basically it's so. Lastly, here we set the primary key as the client ID. And of course, there's more than one way to set the primary key. You can also create a constraint explicitly, especially if you're setting more than one field as the primary key. But in our case here, as it's only this first field, you can use directly primary key, and inside the parentheses, we simply pass the field name. So for the first table, I guess it's this. Let me close the other parentheses. And always don't forget to use the semicolon here at the end of the command line. So create table, client ID, int, not null, client's name, varchar, 255 chars at maximum. And lastly here the set of the primary key, which is the client ID field. So enter. Okay, now we have the first table created, which is the client table. Let me create already the other table, which is the address table. Address, the primary key here will be address ID, or you could modulate it as a weak entity, but I'll just leave it as a strong entity here, mapping to an independent table. Address ID, also int, not null, and the street name, also of type varchar, 255 chars, the street number of type int, the city, the state, and country. Okay, and here we define the primary key as the address ID and the foreign key as the client FK that will be referencing the client table client ID field. Okay, let's press enter and create this second table. Okay, both tables are created, and now if we ask MySQL CLI client to show the tables of this database we are using, the Daniel PM 1982_DB database, it will show these two just created tables, which is the client table and the address table. And we can also use the describe to describe any of them, or show the schema for any of them. Describe client. We have here all the fields. Client only have these fields. The client ID of type int, not null, which is the primary key and has no default values and no extra information. And the other field is the client's name of type varchar with a maximum of 255 chars that can be null, and that is not the primary key, and also has no default values here set and no extra information. And we can also see the address table, which has some more fields, as the address ID of type int, which is not null because it's the primary key and has no default values and no extra information. It has the street name, the street number, the city name, the state, the country. And as the foreign key, we have the client _FK field of type int, which can be null. I don't know if in a real world this would be acceptable to have an address instance that would not relate to any client instance in a client database, but anyways, we have here the client foreign key that can be null or that can not reference any client. So we may have an isolated address here that does not relate to any client. So here at this key type, you can have in MySQL, you can have pre from primary, you can have unique for unique keys that are not necessarily primary keys, and you have the mul, which is actually from multiple, because you can have the same value multiple times as a foreign key for any other table. So don't know actually why they use this, but this mul type here for the key, it's used as the type of any foreign key set in MySQL. So the primary key of the address table will be the address ID, and the foreign key to the client table, and specifically referencing the client ID field of that client table will be field client underline FK. So these are the two tables that we have, and now let's just use now some DML commands. We have used DDL commands to create and define the schema, both of the database as the tables, these two tables. So now let's use some DML commands to do some joinings between them, and just to test here these commands running from inside MySQL CLI client that send these requests to the MySQL server, which in turn is running from inside this MySQL image container. So this is our first client. Okay, now we have two clients in our client table. We can now select star from client, and we have those two rows at our client table. Now let's do the same for the address table. So this row of address ID 1, street name street 1, street number equals 100, city 1, state 1, and country 1, we are setting to the foreign key of value 1, which will be the first client ID whose name is Daniel. So we are setting this row at the address table to the first row at the client table. Okay, and subsequently we'll do the same for the other client. So you're passing this address row as the address for the second client at the client table. Okay, so now we have both tables populated. So you can, if you select star from client, you have these two clients, and if you select star from address, you have these two addresses rows referencing through the client foreign key the two clients we have the client table. So now, as we have two tables and one of the tables referencing the other through the foreign key, we now can do a join, and actually a full outer join. But in the case of MySQL, there is no full outer join, so we gotta simulate it with a union of a left outer join of the first table to another, and unite it with the right outer join of the second table to the first table. So let's simulate that full outer join here. So enter, and here we have a full outer join of the two tables. Here is the two fields, client ID and client name of the first table, and here other fields, address ID, street name, street number, city, state, country, and client foreign key field of the address table that references through the foreign key to the client ID of the first table. So let me just show you that if we updated this address table to set, for example, this client foreign key here to null, when we call the full auto join, we would still have the rows from the address that would eventually not address any client at the result. So let me do an update here of the second table and set this client foreign key of the second address as null, just to show you that the full auto join here works. So update table address, set the client foreign key field value as null, where the client foreign key value is true. So I'm dereferencing the second row of the address so that it's not associated anymore with any client. Oops, we don't have this table here. The table is already the address. Enter. Okay. Now we can see that if we do a selection, select star from address, we have for the second row no referenciation between the address and any of the clients. So now we are only referencing the first client with the first row of the address. And when we call the same command for the full auto join, what we'll have is the display of all the rows, even the rows of clients that are not referenced with any of the rows of address, as well as the rows of the address that do not reference any of the clients. But in any case here, we'll have all the rows of the client 1 and 2, and all the rows of the address, one referencing here the first client and the other referencing no client. So with this, we tested both the DDL commands as the DML SQL commands from inside the MySQL CLI client and for the MySQL server running from inside that MySQL image container. Now I'll just show here the databases again, and we can do a drop on the database I just created, but actually I will not do that because I want to show you that as we persisted all this data to an external folder outside the Docker environment, it will be saved there at that folder we created outside, and we can now delete this container as well as the image if we want, because all the data for these 5 databases, both the 4 databases that are created as default by MySQL installation, as the custom database DanielPM 1982 underline DB that we have created, and inside it these 2 tables with these simple values. All these will be saved at that folder we mapped to the internal volume of the container. So I'll just leave here, exit. Now it's back to the internal environment here, the root directory here of the container volume. We can exit also from it and go back to the external file system of our operating system of Ubuntu. So what I want to do now, as I said, is if you see here sudo docker images, we have this image, and if you see with the ps-a, we have this MySQL container running, created from this image. It's up and running. What I want to do is stop it. So sudo docker stop can use the container ID. So we're stopping this container so that now we can do a sudo docker remove the container. If we check with the ps-a again, there's no container anymore. And if we hadn't mapped the volume from inside that deleted container to a saved local folder outside, here all the data of those databases we changed or created would all be lost, because as soon as we delete or remove any container, all the volume inside is also removed. So we would have lost all the data if we had not mapped it to an external folder. But in our case, as we map it to an external folder, here inside the temp folder, inside this SQL-data folder, here is all the data of those databases, both the default databases as the Daniel PM 1982 _DB custom database we created. We can simply now create another container by running again the same image that we have already downloaded here. Let me just rerun the same command, sudo docker run --name. I'll use the same name for the container here, -p for mapping the ports 3306 and 33060, and we have not used the ports for now, but we have used the mapping of the volume, of the internal volume to the external folder. And for MySQL to retake that data back to the internal container, or actually reuse that data saved outside, we simply have to map the same way by using the -v and the mapping here with the same folder, external folder that we already have with this data, mapping that or having it mapped by the internal folder MySQL where we use to manage that data. So we are simply repeating here the commands, including the mapping of the volume. Also the environment variable here, MySQL root password, also again as root. We could change it to any other password value here, but I'll just keep it as root, as the instance for that MySQL is also root, so I'll just keep the password also as root. And here finally the MySQL colon the tag 8. So let's just run this command all the same again, so that you can see that because of the mapping we are doing here, all the data saved at the SQL folder will be reused by the Docker engine for another and different container it will be creating from that same Docker image. So enter. Okay, it's much faster because we already have the image downloaded, so we're just creating the container from it. Let me just clear here and call docker images and docker ps-a. So as you see here, now we have created another container for that image, and if you compare, the container ID will be different, although the name here is the same because I chose to set the same value name here. The mapping of the ports here is the same, and the mapping of the volume also is the same, although it doesn't show here this mapping of the volume. So let's just get inside this Docker container as we did for the other container we had by using sudo docker exec -it for the iteration mode and the name or the container ID of this other and different new container we've created, having its volume mapped from that external folder with the database data we're now reusing for this container. And here the bash Linux command that will be called from inside this container. So now we're inside this other new container, and we can run the MySQL -u root -p. The password also we set as root. Okay, now we're inside the MySQL CLI client for the MySQL server, which is up and running here along with the container. And if we ask this MySQL CLI client to show the databases, you can see that it actually has all the data that we had before with the other container, although we deleted the other container along with its volume, but we had saved all the data outside, and now we're simply mapping back all the data from the external folder to the internal use inside this other new container we've just created. So all the data of that first container now we have available for this other container, including the database, the custom database recreated. So let's use Daniel PM 1982 underline DB, and let's do the full auto join command again. Okay, and here we have not only the schema of those two tables, but also the data for the full auto join of those tables. So with this, we concluded the demonstration for the use with the MySQL CLI client of the MySQL server from inside the MySQL container. And now what we have to do is simply try to access through those ports we've mapped also from inside the container to outside by using as client now not the MySQL CLI client, but an external client software, in our case the MySQL Workbench. So we'll have the MySQL Workbench installed at our operating system and not inside the Docker container, and we'll access the data or the databases inside the MySQL Docker container through the MySQL server that is running from inside the Docker container. We'll access it from outside through the Workbench software by using those ports. So let me exit the MySQL CLI client. We will not be using it anymore because we are going to use another client, which is the external MySQL Workbench. So we also can exit the container, and we only have to keep the images as well as the Docker container up and running so that we can access from outside the container through the port 3306 and from any MySQL client the SQL server running inside this container. Okay, and for us now to use the MySQL Workbench GUI client for the MySQL server, first we have to install it, because if you see here, I'm now at my operating system, file system. I'm not inside the container anymore, so let me just show you that sudo apt list installed. I have no MySQL server nor any MySQL Workbench installed. You see here, there's none. And what I want to do now is not install the MySQL server, because the server we are running from inside the Docker container from this MySQL default image here we are using. But what I want is to install only the MySQL Workbench so that we can access from outside through these ports we've mapped from the container to the outside world, in this case to the MySQL Workbench client. So let me install here at my file system the MySQL Workbench. So just use the apt package manager from Ubuntu. I'll simply update it. Sudo apt update. And then let me see the name of the MySQL Workbench. Okay, the name is this, MySQL-Workbench. And for this application, MySQL Workbench, as well as for all its dependencies that the apt package manager will install, we can use this command here, sudo apt cache policy, and for that MySQL Workbench, it will show which server will be using to download this application, and we'll see it's not from the MySQL original server. If you see here, we'll be downloading it from the Ubuntu server, http://us.archive.ubuntu.com/ubuntu. It's part of the universe servers that already comes configured with Ubuntu. So if we simply do a sudo apt install MySQL Workbench, it will take this version 8.0.26 from this Ubuntu server, and it might or might not be the ultimate version. So in case you wanna really do the most recommended install, you can see at my YouTube video or playlist regarding the installation of MySQL in the traditional way, not with Docker, but directly to the system, the MySQL server as the MySQL Workbench. You can see there how you can add the MySQL original server to your apt list of additional repositories, so that when you ask apt to install the MySQL-Workbench-community, it will retrieve not from the Ubuntu server or repository, but directly from the MySQL repository. That's the most recommended strategy to install not only MySQL Workbench, but MySQL Server, in case you want to install it in the traditional way. So I have a full video about it. You can look for it at my YouTube in a playlist about how to install MySQL in Linux. But here, as it's simply for demonstration purpose, and also as I already have the MySQL server running from inside the Docker container, I will not depend on any installation of MySQL server here at my operating system. I'll just be installing the MySQL Workbench. I'll not have this additional effort to install an additional repository or the MySQL original repository. So just install from Ubuntu repository. So sudo apt install and the name of the application we are installing, which in the case of Ubuntu repository it is called, or it is named, MySQL-Workbench. So enter, install it, and it's installing MySQL Workbench and all the dependencies it will be needing to run, except the MySQL server and the MySQL server dependencies that will continue to run from inside the Docker container. We are simply installing here the client, an external client, so that we can test to access through that external client and through those mapped ports the MySQL server running from inside the running Docker container for the MySQL official image we are using. So we will have this external MySQL Workbench GUI client accessing or making requests to the MySQL server running from inside the Docker container with the volume mapped to that same folder we used and where we have all those databases, including the custom database we created and the tables saved inside. So let's just wait it to finish installing MySQL Workbench client, and then we'll connect MySQL Workbench with the Docker container MySQL server. And the same we'll do in other videos for connecting an external springboot client outside the container running MySQL server. We'll connect from the application, an external application, to the MySQL server inside a Docker container, the same way here, through those mapped ports we are using, 3306 and 33060. So we can connect from an official MySQL client, either the CLI client or a GUI client, as here with the Workbench, or we can connect from a Spring Boot application, for example, accessing that same MySQL server inside the Docker container. Okay, so it's finished. And now for running, we simply use MySQL-Workbench. And it will run the Workbench we've just installed. Here at the local instance, as you see, it will connect to the 3306 operating system port, which is mapped to the 3306 port inside the Docker container we are still running. Let me open here another instance of the terminal, only to show you that we're still running the Docker container with the MySQL server, which is mapped to the outside world through these ports we also mapped from inside the container to the outside. So status is up and running, which means the MySQL server is also up and running inside that same Docker container we've used with the container internal MySQL CLI client, but now we'll be using the same server with the external MySQL Workbench GUI client. So if we open here the local instance of the MySQL, it is connected to the MySQL server inside the Docker container through this port. So we just pass here the root, which will also be root. And then we access the internal MySQL server inside the Docker container. So it's running, and we can see here the schemas or the databases we have saved, not simply inside the volume inside the Docker container, but at that external folder we have at home temp SQL data folder mapped to the Docker container but kept outside, so that we also can keep the data saved when the containers are deleted. So here we have that custom database, the NPM 1982 _db that we have created with those two tables address and client we created. And here we can, for example, select all the clients. We have only these two clients, or select all the addresses. We have these two addresses. Okay, now let's do the same full auto join query we did, but now instead of from the internal MySQL CLI client, from this external MySQL Workbench GUI client. Here we should set this database as default schema so that we don't have to specify it at the query. And now we can write the same query we wrote with the other client we tested. So, okay, this is that same query for a simulation of the full auto join. As in MySQL, we don't have this DML command specifically, as we have, for example, in Oracle database. So here we have to simulate with an union of the left outer join of both tables with the right outer join of the same two tables. And this will give us, after we execute, the same full outer join view or result for the two clients, including the second client without any address, as well as for the two addresses, including the one that is referencing the first client, as well as the other address that is not referencing any client here, with a null foreign key for the client's table. Okay, so that's it. This is the database that we've created, and this is the SYS database, and all these databases that we've managed both at the MySQL internal CLI client as here at the MySQL external Workbench GUI client are all of them saved inside this temp SQL data directory, so we can reuse this data or databases for any container that we create for our MySQL image, and then connect to that MySQL server running inside the Docker container from any client outside or from any custom application or Java application, for example, a springboot application, connecting to those same databases. Okay, so this is it for this one more video about Docker. And in this video we saw very important things, which are how to map inner volumes from Docker containers to outside folders at our OS file system in order to save the data from, for example, the databases we are using and all the tables and data inside. And we also reviewed how to map ports, including multiple ports in this case. You have to use multiple parameters -p, one parameter for each port. We also saw how to set environment variables for our Docker containers. And finally, we tested the MySQL server running inside the Docker container created from the Docker image from dockerhub by using the MySQL CLI client from inside the same container where the MySQL server is running, and also an external client, which in our case was the MySQL Workbench that we installed outside Docker or outside the volume of the Docker container at our operating system. We kept running the MySQL server from inside the Docker container, but we used an external client, MySQL Workbench client, to access it from outside through the mapped port, and still keeping also the volume mapped to an outside folder. So we tested that as we mapped the volume to an outside folder, we could also delete the container and create other different containers, still mapped to that same external folder, and we still had the same data available from the new container or any other container we created, mapping the volume for that mapped folder outside. And at the next videos, I'll show you not simply how to access from clients the MySQL server running inside a Docker container, but also how to run a springboot application from one container and access the MySQL server running from another container. So we start working with multiple containers or clusters of containers starting from the next videos. So thanks again for your time and see you in the next video.